questions 21 to 25 of the 2001 grade 10 AMC 10. A right circular cylinder with its diameter equal to its height is inscribed in a right circular cone. The cone has diameter 10 and altitude 12, and the axis of the cylinder and cone coincide. Find the radius of the cylinder. So we will of course need a diagram. Okay, so I've drawn a cone in blue and a right circular cylinder in red, and they are sitting on the same axes as the question states. And now we have to label everything and take it from there. So let's try to label this as best we can. First thing, of course, we're going to have to draw a height from the top all the way to the bottom like that. And we are going to draw some diameters. Here's one, and I think all the others we have so far. So let's start labeling this. So first, what does the question give us? The right circular cylinder has a diameter equal to its height. So the diameter is equal to its height. So the height is from here to here. That's the height. So I'll label that H right there. That blue segment is the height of the right circular cylinder. And diameter is from here to here, and they're equal. And we also know that diameter is equal to 2 times the radius. So this is the radius, and this is the radius, like that. And then, let's see, what else can we label? We can label the 2 radius down here. It's the same. It's the same. Top and bottom are the same. And then, do they give us any other question? Oh yeah, right here. The cone has a diameter of 10. So what they're saying is this cone right here, all the way across, is 10. So we will label this Y, and therefore Y plus R plus R plus Y is equal to 10. So 2R plus 2Y is equal to 10. R plus Y is equal to 5. All right, let's see what else we can do here. Altitude is 12. The altitude of this cone is 12. So that basically means that from the top all the way down to the bottom like that is 12. So instead of making this more messy, I'm just going to call this part H right here, or X probably is a better term, and therefore X plus H is 12. All right, and I think that is all we get. So now we have to work with this. So how do we proceed from here? Well, the first thing that I would like to show you is something known as similar triangles. And I'm sure you have worked with similar triangles in the past, so you should be able to identify which 2 triangles are similar. It's this one right here, this one, along with the big one, all the way down to the bottom, like that. So those 2 triangles we will use in our relationship. So for the first one, we've got X over R is equal to, in the big one, it'll be the full height, so that's X plus H, over the full base, which is R plus Y. And I think at this point we can substitute a lot of the things. So X plus H is right here. It's 12. R plus Y. It's down here. We figured that out earlier from the information that was given to us in the question. So that's 5. X, let's see here. Well, we can isolate this one. This one will give us X is equal to 12 minus H. And then R is just R. And I think that's about as far as we can go. Is there anything else that we can substitute for? I think we can. This, because we want this all in terms of one variable, right? And this one right here, this relationship. 2r is equal to h, so yeah, that'll work. So we got 12 minus 2r. There we go. We've got it all in terms of one variable. Great. Just with the information that was given in the question. Okay, so now we cross multiply, so we have 60 minus 10r is equal to 12r. So 60 is equal to 22r, and therefore r is equal to 60 over 22. And this is, in lowest terms, 30 over 11. And that's what they want us to figure out, the cylinder, the radius of the cylinder, 30 over 11. And therefore the answer is for 21B. In the magic square shown, the sums of the numbers in each row, column, and diagonal are the same. 5 of these numbers are represented by V, W, X, Y, and Z. Find Y plus Z. All right, so find Y plus Z. That is our ultimate goal. Okay. And where would you like to begin here? There's a whole bunch of possibilities. It doesn't really matter. I guess we can just start with this right here. 25 plus z plus 21 is equal to, all the sums are the same, the rows, the columns, the diagonals, so we can just use any of these. So that means any of these rows, columns, and diagonals will have the same sum. So this is the first one. And this one will give you z plus 3, if you add and subtract all the numbers, is equal to v. So that means z is equal to v minus 3. Or either way, so this z, or this v rather, right here, we've gotten in terms of z plus 3, like that. All right? So that's the first one. Where would you like to go next? Z, probably up here, z plus 3, x and 21, this diagonal right there. So we have z plus 3 plus x plus 21, and we can make that equal to the bottom row as we did previously. So the z's cancel, so that's great. I think we'll be able to get x by doing this, and we do. This is 22. Perfect. So we've got one number. Great. Let's keep going now. Probably going to need a little bit of space here. Where can we go next? I think this one right here. This 18x and y. This one will be useful. So 18 plus x, but we know that's 22 plus y is equal to, and I think that bottom row is helping us out a lot, so let's use it again, see what we get. And this looks like y is equal to z plus 6. All right. We're starting to get things in terms of z. That's good. Because if we have them all in terms of one variable, that's going to help us. Let's see, where do we go next? I think this diagonal will help us right here, this one. So that's 25 plus x, which is 22, plus w, is equal to, we'll use that top column there, w plus 24 plus z plus 3. And the w's cancel, and that just leaves us with z is equal to 47 minus 27, 20. All right, great. We've got, all right, so we have everything now. So y plus z, y is right here, z plus 6 plus z. This is 2z plus 6, and z is 20, so 2 times 20 plus 6, which would be 46. And therefore, The answer is D. A box contains exactly 5 chips, 3 red and 2 white. Chips are randomly removed one at a time without replacement until all the red chips are drawn or all the white chips are drawn. What is the probability that the last chip drawn is white? So we have 3 red chips and we have 2 white chips. And you're picking them out one at a time, and you stop when you have pulled out all the red chips or all the white chips. So for example, we've got one scenario R, 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 W, W, right? Now, this is a scenario of how you can arrange these 5 chips. But read the question carefully. The chips are randomly removed one at a time without replacement until all the red chips are drawn or all the white chips are drawn. So in this case, first one you take out was red, then red, then red. Because at this point you have taken out all the red chips, you're finished. And that's what they mean. You don't need to keep going. So I'll give you another scenario. Red, red, W, red, W. Now you think about this and think, when do I stop? You stop as soon as you either have pulled out all the red chips or you've pulled out all the white chips. In this case, you've pulled out all the red chips when you get to that point, because you'll notice all 3 red chips have been taken out of the box. You don't need to keep going. How about a scenario that involves stopping because you've taken out all the white chips? Well, that would be something like R, R, W, W, R. There's others, but this is just one example. Here, once you've pulled out that second and final W chip, you stop. You see what I mean? All right, so that is basically what they're asking. So we just have to figure out all the possible pair orderings, and then we'll look at when we stopped as the last chip being white. The scenarios in which the last chip drawn was white, and that is when we stopped because both white chips had been removed. Okay, so we got 2 of these. Let's see how many more we have. Well, actually, we have 3 of them. We have to find out some more. So R, W, R, R, W. I'll just write out the scenarios. And I think we've got probably 5 more like that. W, R, R, W, R, R, W, W, R, R. And I think 2 more would probably be completing all the possibilities. These are all the possibilities. And then now let's figure out, when are we stopping? In this 4th one right here, we are stopping right here. Why? Because we pulled out all 3 reds. In this next one, we will stop at this point right here. And over here, we will stop. Either you're stopping when you've pulled out 3 red or 2 white. So we're going to stop right here. Similarly here, 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 and here. Now, the question is asking, what is the probability that the last chip drawn is white? Well, first of all, how many different arrangements are there? There's 10. And how many of these arrangements was the last one white? I'm not talking about the last one in my orders. I'm talking about the last one drawn. Well, this one, the last one drawn was red, because at that point you stopped. And then in this one, it's also red. This is white. So here's 1. This one red, red. This one, the last one drawn, is white, 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 white. So we got 1, 2, 3, 4, 6 of them. 6 of them have a scenario where the last chip drawn was white and then you stopped because of the criteria in this question, which says that until all the red chips are drawn or all the white chips are drawn. So this lowest terms gives us 3 over 5. So 23, the answer is D. In trapezoid ABCD, AB and CD are perpendicular to AD, with AB plus CD equal to BC. AB is less than CD and AD is 7. What is AB times CD? All right, well, most definitely we'll need a diagram to explain this. All right, so here's a trapezoid, which I hope is relatively close to the criteria that they are giving us. So let's start labeling this. A, B, C, and D. A, B, and C, D are perpendicular to AD, so that makes that a right triangle, or right angle, I should say. And AB plus CD are equal to BC. So if this is X and this is Y and this is Z, that means X plus Y is equal to Z. All right. AB is less than CD. All right. I made it in a way that that is true. And AD is equal to 7. What is AB times CD? So that would be, what is find X times Y? AB times CD. Okay. So where do we proceed from here? I think a line from B perpendicular to DC would help us, like that. Perpendicular like that. And then therefore that would make it a right triangle right there. And then this is 7. And this region here is Y minus X, right? Because the whole thing was Y, and the top it's X, so that's Y minus X. All right, so I think we can get a Pythagorean relationship with this Pythagorean theorem. So we have 7 squared plus Y minus X squared is equal to Z squared. 49 plus Y minus X squared is equal to Z squared, but Z is X plus Y, so X plus Y squared. So 49 plus Y squared minus 2XY plus X squared is equal to X squared plus 2XY plus Y squared. And the Y squareds go, X squareds go, so all we're left with is 4XY is equal to 49. Therefore, XY is equal to 49 over 4. And 49 over 4 is 24.5 divided by 2, so 12.25. And that's what they're asking us to find, and that would be choice B. How many positive integers not exceeding 2001 are multiples of 3 or 4 but not 5? Okay, so we have 2001. When you divide by 3, it'll give you the number of multiples of 3, and that is 667, the closest integer value. 2001 divided by 3 is actually exactly equal to 667. And then now 2001 divided by 4 is a little more than 500, but we are looking for the number of multiples, so we're obviously going to be looking for just the integer values. So this represents the number of multiples of 3, and this represents the number of multiples of 4 between 1 and 2001. So this looks like a total of 667 plus 500. But there's a problem that we have counted a few of these twice. Which ones? Multiples of 3 times 4, which is 12. Multiples of 12 have been counted twice. So how many multiples of 12 are there, first of all? Well, same kind of scenario, 2001 divided by 12, and you take the integer value that's closest to that, and that is 166. So now the total number of integers that are multiples of 3 or 4 from 1 to 2001 is 667 plus 500, and we have to subtract the 166 that was counted twice. So therefore this is 1001 unique multiples of 3 and 4. All right, so now we've got the first part. Now we have to look at not multiples of 5. So of all of these numbers that we got, we have to take out the ones that are multiples of 5. So how do we do that? So of all the multiples of 3 and 4, we must now remove those that are multiples of 5. So let's start with numbers that are multiples of 3 and 5. And those numbers, since they are multiples of 3 and 5, they are multiples of 15. So very similarly, you take 2001 divided by 15 and take the integer value of that, and you get 133. That's how many numbers between 1 and 2001 are multiples of 15. So these are the bad guys. Now we have to figure out how many are multiples of 4 and 5. Remember, of all the ones that we figured out in the first part of the question, we have to now get rid of the ones that are also multiples of 5. Well, multiples of 4 and 15 are multiples of 20. So these are the ones that we have to get rid of. Of all the ones from 1 to 2001, you get rid of the ones that are multiples of 20, and this is about 100. So now, very similarly, like we did earlier, we have to get rid of doubles because we've overcounted some of these. Which ones have we overcounted? The ones that are multiples of 3, 4, and 5. So if you have a number that's a multiple of 3 and a multiple of 4 and a multiple of 5, that has been overcounted. So that essentially means multiples of 3 times 4 times 5, which is 60, have been counted twice. So we got to get rid of those. So that's going to be 2001 divided by 60. Take the integer value, and that gives you 33. So now finally we have 133, 133. So 133 plus 100, but then we have to subtract the multiples of 60 that were counted twice, and it gives you 200. This represents the unique multiples of 3 and 5 and the unique multiples of 4 and 5. So these are the ones that we need to remove. Remove from what? Our original list, which was 1001. So final grand finale of this question is you take the original list, which was multiples of 3 and multiples of 4, and subtract from it all of those numbers that are also multiples of 5. And therefore the final answer is 801. And that would be choice B.